In this video, we're going to combine T3D with RayTK using the new RayTK Volumes add-on. T3D is a powerful set of tools from Josef Pelz for working with 3D textures in Touch Designer. RayTK Volumes extends RayTK to work with T3D and other volumetric techniques. By combining the two, we can use RayTK to create shapes in 3D and then use T3D to apply feedback to create trails that follow the shapes as they move. The RayTK Volumes add-on is available through my Patreon, and T3D is available from Josef's Patreon. There are links to both of those in the video description. The first step is to get the T3D library. Once you've downloaded that file, drag it into a new project. It will immediately hide itself, but you'll see an indicator in the top right of the main window that says T3D. And when you open the regular Create Op dialog, there's now a new tab with a whole new set of operators there. The next step is to download the main RayTK library from GitHub. Go up to the root of your project outside of that main project comp, and then drag that talks file in. I recommend doing this at the root outside of the project comp because if it's in the same network as your scene, you end up getting a lot of these data connections, which I find to be kind of confusing visually. The third step is to get the RayTK Volumes add-on from Patreon. There's another link to that in the description. Drag that talks file into the project next to the main RayTK comp, and then head back into the main project comp. We'll start by creating the shape that will be the basis of the scene. We're going to keep this part fairly simple, but you can easily swap in different kinds of shapes later on. Open the RayTK palette using the Alt-R shortcut, and then we're going to create a box frame SDF. Then open the palette again, Alt-R, create a rotate. And last, open the palette one more time and create a texture 3D render. And if you don't see this in the palette, that means that you need to load the RayTK Volumes talks as well as the main one. And then connect up the rotate to its first input. Add a null top to the end, connected to that first output so you can see a preview of the 3D texture. You can right-click it, do View to open it in a pop-up window, but I'm going to be using a panel here just to fit things on the screen for the tutorial. So the preview here shows a series of depth slices. So starting at the front and then going backwards, or possibly the reverse, I don't recall. And then within each little square, we've got a sort of cross-section slice of our shape. Go over to the rotate and then try changing some of the rotation here. And notice that in a lot of cases, we end up losing parts of the shape that seem to be going kind of out of frame. This is one of the key differences between 3D textures and working exclusively in RayTK. 3D textures have a limited box that they cover. On the texture 3D render, we have a setting here that defines where the center of that box is, and then another setting for the size of the box. And anything that's outside of that box doesn't end up in the texture that comes out of it. Try increasing all the parts of the size parameter up to about 2. And notice how things get smaller in the preview when we do that, even though we're scaling it up. And that's because we are capturing now a larger volume and fitting it into that texture, sort of like zooming out on a camera. With the size set to 2, we go over to our rotate. We have enough room that things are mostly not getting cut off, at least on the edges. It can be a little bit hard to visualize what's going on in here without some sort of preview. But before we do that, let's just add some quick animation on the rotate. So select the rotate operator and then open RayTK's editor tools menu with Alt-Shift-R. And then under animate with speed, choose rotate XYZ. Then on the speed generator, set the first 3 parts of the value multiplier to something like 30, since this is going to be in angles, so we're going to want larger numbers. Then we can use the different parts of the speed parameter to change how much it's spinning on each axis, and then use the slider here to control the overall speed of all the axes. Pick a combination that you like that gets things moving so that we have some variation in that space. Now we can move on to rendering the 3D texture. And we can do that using operators from the T3D library to render this texture using a different form of ray marching than what is typically used in RayTK. Open the regular Touch Designer Op Create dialog, and then go to the T3D tab, and then choose Surface. And connect up that mill top to the first input. This operator uses a clever trick to do ray marching, but within Touch Designer's native rendering system. It uses a SOP cube that it places into space, and then as a material, it has a whole ray marching system built in. This is a similar approach to what the Fuse library for VVV uses. I'll probably end up adding a similar technique to RayTK in the near future because it seems pretty handy. To render this to an image, create a render top. And if you are on a non-commercial license, you can increase the resolution or just leave it at 1280 by 720 if you are on a non-commercial license. To get anything to actually show up in there, we need to add a camera. So one option would be to use a standard camera comp, but I like to use the one from the Touch Designer palette in the tools section called Camera Viewport. So you can drag one of those in and then close that palette. The Camera Viewport extends the regular camera comp, adding some kind of improved user interface interaction. So drag this onto the render top and put it into the camera parameter. And then we can drag the render top onto the camera viewport and have it set the render top. So that uses that to show in this little preview window here. We can't see anything yet though, because there are no lights in the scene. So let's create a light comp. And then position that somewhere off to the side, maybe like 4, 5, 5 or so. Then we can use the camera viewport. If we want to right-click that and choose View, it'll pop up a new window for it. I'm using this preview pane on the side. So the camera viewport lets you use the kind of mouse interactions that you are used to from regular viewers, but in a panel. So we can move around, look at this thing from different sides. So back on the light, let's pick a color for this one. I'm going to go with a pale greenish blue. Maybe a little more blue, something like that. And then just to make things a little bit more varied visually, let's create another light and place that somewhere else, maybe off on the other side, like -4 and 6 and I don't know, maybe 4 or something. And then pick a different color for this one. So I'm going to go with something that's kind of more orangey. So now that we can actually see what's being rendered out of that 3D texture using this ray marching technique, we can see that there's a bunch of weird stuff going on in here. If you zoom in, you can see how it looks kind of pixelated, but if you really zoom in, we'll see that there are curves. Those aren't like hard pixel edges, just as actual pixels. What it is pixelization in three-dimensional space. And it's blending out some of the barriers between the individual voxels, which is a term for a pixel in a three-dimensional space. But there's still only a finite number of those, and so things are going to get kind of distorted like that. We can go back over to our texture 3D render and increase the resolution here. Before you do that, though, it's important to note that 3D textures can pretty easily take up a lot more GPU memory than you might think. And that's because instead of just 2 axes, it's got an entire third one. So it's like having 64 by 64 grids instead of, just one layer of that. And when GPU memory gets too low, you can get some kind of weird graphics problems, including issues that show up in other programs that are not Touch Designer and all kinds of weirdness. So when you're increasing it, start with small increases until things look decent, but leave it as low as you can with it still looking okay. So I'm going to go up to maybe like 128. And I'm going to try a little bit higher, or double that, 256. These don't necessarily have to be powers of 2, but just my programmer training tells me to do that. So 256 looks okay. There's still some distortion in there, but there are some other techniques that we're going to try to address that without having to add more resolution. Different GPUs can have very different memory capacities. So what works on the 4080 Super that I'm using may be too much if you are using a laptop. So you may need to keep it lower. Or if you have a fancy Quadro card, you might be able to go way higher than this. It's also good practice to save before you do a lot of changes to increase resolution, especially if you're going to try going high, just to make sure that things don't get lost when you crash. So we haven't really fully solved the pixelization here, but it's getting closer. If we were only raising the resolution, it'd still be pretty hard to get that to fully smooth out. So we're going to try some additional techniques on top of that. The first technique is to smooth out the hard edges into gradients. So to get a sense of what this is like, pop open a viewer for that 3D texture. And I'm just going to show it in the side panel. If you zoom in, we can see that we get these really hard edges. And that's the kind of pixelization that we're trying to deal with. So with a larger resolution, those pixels are a lot smaller, but they're definitely still there. And we still have this really hard aliased edge. One option would be to use the T3D blur operator, which we are actually going to end up doing in a bit, but right now, let's try using a different approach first. So this is a good time to talk about density. Density is an attribute that can be assigned to SDFs or volumes, similar to the color attribute. For normal ray marshing, it doesn't get used, but it's important for volumetric rendering and 3D textures. Take a look at the texture 3D render and create 2 more nulls and look at the other 2 outputs that we have coming out of there. The second one is going to be transparent everywhere except for where the shapes are, which is going to be black, and that's because we haven't assigned a color attribute, but we aren't actually going to need that. And then the third one is SDF data. So that's the distance from the surface, so it gets larger the further away it gets from the edge. And just know that this viewer is zoomed in, so if it looks different on your screen, that's probably why. The first one, though, the one that we've already been using, is for density. By default, if you don't tell it what density to apply to that shape. It's just going to fill the inside with a density of 1 and the outside with 0. We can override that behavior by adding a new assign density operator. So just making a little room there. And we can delete these other 2 tops. So open the palette one more time with Alt-R and create an assign density operator. And then insert that right after the rotate. By default, that isn't doing anything, and this is because the default settings match what it would be like if you didn't have that there at all. But now we have this blending setting, so let's try bringing that up a bit. So that smooths out some of those edges there. It does it by pulling inwards from the border of the surface rather than kind of spreading outwards. There might be an option in a later version of the toolkit to have it spread outwards instead of inwards, but for now, that's what it is. You can also use the offset parameter here to expand them, though you are going to come into a limit there if you try to get it to expand much beyond the regular range there. That's because of a setting in Texture 3D Renderer, but let's for now just leave that at 0. Now let's go back over to the other renderer, the camera with the camera viewport. And switch over to that viewer. So now if we look at the contents there, we're going to see that things are smoother. Still definitely some noticeable issues though. On the T3D surface operator, go to that surface parameter page and try changing this threshold. So the threshold here is the minimum density that it considers to be filled in. So if you lower it, then it considers that whole, more of that faded out region to be part of the shape. And if you raise it, it only gets the kind of inner core. But I'm going to leave that at the default of 0.5. And we can raise it slightly, just a little bit, and that will help round things out a little bit. So there's a little bit less of that pixelization in space. Another thing to note is that if you go zoom in too far, the surface disappears because of how it's filling in that box. At this point, we can try inserting some blur into the chain. The regular blur operator, regular blur top, does not handle 3D textures, and you'll actually get an error on it if you try. In later versions of Touch Designer, this might be supported, but for now, it does not work. But fortunately, T3D has its own special version of blur. So we can create one of those and insert it between the null and our surface. And that already has smoothed things out quite a bit. On the blur page there, you can increase the number of passes to have it smooth out even more. But do keep in mind that blur can be expensive, especially when it's dealing with a lot of pixels, and 3D textures often have a lot of pixels. So I'm usually going to end up leaving that at 1 or 2. And you can use this double step parameter to make the blur passes more spread out without having more of them. But I think just a default of 1 pass does a good enough job for what we're trying to do here. All of this is great, but we could have just used a regular Raymarch Render 3D to render the SDF and get something that looks pretty similar to this. But now that we are using a 3D texture, there are a bunch of things that we can do that would be basically impossible to do with just RayTK on its own. The most exciting of those, at least for me, is feedback. To create another null top and insert it between the first one and the blur, this is going to be the end of our feedback chain. Then create a feedback top, connect the first null to it, and then drag the second one into its target parameter. We can't use the regular add operator for tops because it doesn't support 3D, but the T3D library has its own version of that. So create one of those, the add operator, connect the feedback to the second input and the first null to the first input, and then connect to the second null. So then we start to see the shape is filling up that volume of space. But because it's not fading out at all, it's just becoming one giant solid blob. So we need to have it reduce the density over time and sort of fade out, giving you more of a trail look rather than just a filled in shape. To do that, let's create a T3D math operator and insert it between the feedback and the add. Then on the multiply page, decrease that multiply amount by just a little bit. And since this is a feedback loop, we want really slight changes because they add up as the stuff goes through the loop. Anything that is 1 or larger is just always going to fill up. And then anything that is too low is going to disappear pretty much immediately, and then you don't really have your trails. So you need to find a value that is really close to 1, but just below it. So I'm going to go with 0.99. And that gives us just a little bit of trail, but the next step is going to accentuate that a bit. Now we get to the fun part where we can insert operators into our feedback loop to get all kinds of different effects. So just making a little room for myself over here. Create a T3D displace operator, and then insert that between the feedback and the math. And we're going to see an error on this, and it's because we need to give it a second input that's going to tell it how much to displace at each spot. And that second input needs to be a 3D texture, just like the first input. To create a T3D noise operator and connect that up to that second input. Then to make sure that we have the same amount of detail in the different parts, let's go back over to our texture 3D render, right-click its resolution parameter, choose copy, and then go to the noise operator, go to the comment page, right-click its resolution, choose paste reference. So now they'll always match. Then for the pixel format, change that to 32-bit RGBA. That allows us to have higher precision and also have negative values. With that set up, we are seeing something, but it is barely noticeable. And that's because we are applying way too much displacement. Remember that in feedback loops, you only want to do very slight changes. So let's go over to our displace, and on that first parameter page, drop the strength down a whole lot. So just a little bit above 0. And we can already see that we get these trails coming off and they're all being pushed mostly to one side. The reason that they are just going in one direction there is because we need to change the settings on our noise. First, switch off the monochrome, and that's going to give it a different value for each axis. And then we're going to decrease the offset to 0. So now it's centered at 0. You can also try playing around with that and having an offset that's slightly higher or slightly lower, but an offset of 0 will keep it kind of in place. To add a little bit of motion to this, with that noise operator selected, open RayTK's Editor Tools menu with Alt-Shift-R, and then under Animate the Speed, choose Translate and do the top part, not one of the individual parts. Then on the speed generator, you can control how fast the noise moves in each axis, and then use the slider to kind of control the overall speed. Let's give ourselves a little bit more room to work with here. So now that we have the displacement, we can add another type of transformation in there. So create a T3D transform, and then insert that between the displace and the map. Again, this is a feedback loop, so you want gradual changes, but you can try adding a little bit of translate, which will kind of make everything flow in one direction. Or you can even do rotate, which will get it wrapping around. And if you do scale, you can get it to either pull inward or push outward. So play around with those, get something that you like. And that's it for this scene. So to recap, we are using RayTK to create an SDF based on box frame and applying some rotation animated, assigning a density to it to blend out the edges, and then rendering it out into a 3D texture. Then we are using a feedback loop with a bunch of T3D operators to add that displacement and offsetting. Then we apply some blurring to smooth things out a bit, and we finally render using the T3D surface operator with a render top and camera and light. There are lots of different things that you can do with this from here. Like swapping in different kinds of SDFs or different transforms within that RayTK section, or trying out different effects within the feedback loop, or different lighting or materials, or lots of different options. Anyway, I look forward to seeing what you all do with this. If you post on social media, use the RayTK hashtag, and at least on Instagram, tag me if there's stuff that you want to show off. If you're watching this, you are probably already subscribed to my Patreon, but if not, consider joining. It's a great way to support RayTK development, and you get access to the RayTK Discord, early access to tutorials, RayTK add-ons, and a whole bunch of other stuff. Thanks for watching, and make sure to like and subscribe.